So, good morning to everyone. So, today we are here to discuss the very basic part of some uh, very basics of complex functions. So, for that, what we'll be addressing here is that we'll address limits, okay, then continuity and differentiability, okay, differentiability of a complex function, okay, differentiability of complex function, limits, continuity, differentiability of complex function. Okay, so we know that whenever we said about limit, we do represent, that is like, how do we represent limit z tends to 0, right? So limit, normally we say that z tends to z0. Okay, so that is, it is basically that arrow I designated as, it is tends to 0, that is z is going to be z0. So that condition we used to care, so our z tends to, okay, fine. Okay, so what it means is that basically many ways we do represent this same thing, that is you can represent, that is limit z tends to 0. Sometimes you will represent like lt z tends to z0. So all what it means is that where z is in what, z is in neighborhood of the, so it basically means that it is very near to neighborhood of z0. Okay, so that is, this arrow is actually representing what, it is 10 to the 10 to z0, that is z is approximately, it is coming to the value that is z0. So whenever you consider a real and a complex variable, so how do we this represent this representation? Normally when you consider a real variable, okay, so we'll have a real variable here, and also we have a complex variable case, complex variable. In both cases, how this representation will looks different. So normally when you consider a real variable, for example, let me just say that x tends to x0. Okay, so it is basically, it is a one dimensional one, right? So this is a one dimensional representation, that is the, for example, x is the length, this is actually approaching to x0. So what normally what it means is that whenever you represent a number line, whenever you represent a number line, so that is, this is the number line that is already has been learned in your very basic classes. So which has the value -3, -2, -1 and 0, and 1, 2, 3 as the number line corresponding to that. And what x approach to x0 along number line, it means is that it is either coming from, for example, this is my x0, so either from this part or from the left side or right side, it is approaching to the value the x0, that is basically mean. And x and x0 can be joined only by these two number lines. Okay, and similarly, and if you consider in the case of a complex variable case, where I said limit z tends to z0. Okay, so it is a representation of not what, it is not a representation of one dimensional, it is a representation of two dimensional, because we know that what is z is x plus iy, so it involves two coordinates, that is x and y. So we can represent, this is a two-dimensional representation. Okay, so any complex variable is a two-dimensional representation where z approaches to z0 along a path or straight curve. Okay, so it is not a one-dimensional one. So where you're tracing the path, we are actually going to get is what, you will be getting a path or straight or curved path you will be getting in that case. Okay, so z approaches to, so when you say z tends to z0, okay, so along a particular path, along a path, so it can be either a straight path, okay, or sometimes it will be a curved path. So it depends upon how do it take. So normally what z is means, I already said z is x plus iy. Okay, then what will be z0? Z0 will be what? It will be x0 plus iy0. Right? So z0 means it is a coordinate. When you consider coordinate, it is x0 y0 point. So whenever you consider, so z0 will be represented like this. Okay, so z and z0, so these are 2 points can be joined by infinite number of curves. So let me just show you an example before saying it. That means when you 1 minute. Okay, so whenever you say that, it is actually z and z0, actually there are 2 points. Okay, z and z0 are 2 points in a coordinate system. Okay, so it can be joined by infinite number of coordinate system. Infinite number of curves can be accommodated in order to connect between this z and z0. But in earlier case, real variable where we considering as a single one-dimensional case, where we are actually approaching from the left and right side of a number line, so which is actually approaching to x0. That is a real variable case. So when you consider in any case of complex variable that is approaching to z0, so which will be actually a path. It can be either a straight or curved path, so which is connecting with 2 points in a case. Okay, so let me make an example for you, for that you will understand what I'm meaning. So then you'll understand. So let me just represent a box here. Okay, so this box has a function f of z. Okay, so f of z, so for example the limit I am keeping is limit z tends to 0. Okay, so let me draw it a proper way. So that is, I'll have a function okay, so I'll have a function limit z tends to 0, that is f of z is a function. In that case, limit is z tends to 0. So what it means is that the z0 value will be what? Z0 equal to 0 in this case, right? So when you consider this an example, so this is one of the example we are taking here. So where z0 equal to what? Z0 equal to 0 in this case. Okay, so that means what? Z0 equal to 0 means what? That is x0 plus I y0 equal to what? It is equal to 0 plus I0. So that is, when you say that x0 will be equal to 0 and y0 will be equal to 0 in this case. Okay, so that means when you consider the coordinate or the point in a plane, so this will be 0 0. Okay, x0 y0 will be 0 0, so it will be where? It will be at the origin. Okay, so let me just consider this case in a different fashion. That is, I'll be first treating with a function. Okay, so let me draw another box here. So in that I'll be representing here, allow limit x tends to 0. Okay, and y tends to 0. Okay, that is f of z. So this will be what? This will be a representation will have along y axis. Okay, I will draw you and I will show you how it comes. And the next one will be the possible way is it can be either this way. That is the first way, is it will be you are applying the limit with respect to limit y tends to 0. Okay, and then x tends to 0. So in both cases, so in these cases what you will be observing is that you will be along x-axis you can trace out the path. And the third case, so it is a case that is more important to us, that is when you represent this function like this, that is here limit z tends to 0. Okay, limit z tends to 0, f of z. So it will be along any curve. Okay, so what will be gonna get along any curve will be obtaining in this, so such that the curve having the value that y is equal to mx, it can be either also take the value that is y is equal to x square, and it also can take the value that is y is equal to x raised to 3. Okay, so and many more such kind of representation can be you can identify in the case. So what I means is that, let me just represent here. Okay, so let me draw this one. So here, so I'll have y along y-axis, and along x-axis I'll have x. Okay, and as I said, z0 will be equal to what? It will be at the origin, so this will be equal to 0 0 0. Okay, so in the first case, when you address the first case, this is the first case I have addressed, and second case is this one, and this is the third case. So in the first case, if I represent, what I will be getting is that I will be having the value, for example, this is my zxy. Okay, this is zxy. So what I getting is that this will be having a path corresponding to along this one. Okay, and the second case, let me draw this one. It will be the along x-axis will have a representation that is equal to the second case. So in the third case, when you represent any curve, so what you're gonna get is that we know that zxy, so it is a projection along this one, right? So this is, I can straightly connect to this one. So this is the z tends to z0 case, that is the zxy actually approaching to the origin. So this is how we represent this one, and the direction will be equal to, it is coming towards origin. Okay, that is a case for z is tends to z0 means. And if I do represent what is y is equal to, this is a corresponding equation, it will be equal to y is equal to mx. Okay, and whenever you trace a path like this, so I will also have a function that is y is equal to x square. Y is equal to x square will have a path like, it will be almost like a curved path. So this is equal to y is equal to x square. Okay, then you consider again y equal to x cube. So this is again like a curve you will obtain, that is equal to y is equal to x cube. And similar fashion, you can actually, this all curve is directing towards where? It is from zxy to z0. So that is basically the limit representation meaning is that. Okay, it is all the values zxy actually coming towards what? Towards this origin representation when you consider z is tends to z0 means. So what we will be getting is that we will be getting a curved path that is obtained like this. So the curve will be y is equal to mx, or y is equal to x square, y is equal to x cube, any representation. So this is actually representing or connecting between 2 points. So it will be showing a infinite number of curves you can actually accommodate by connecting z and z0. Okay, so now if I represent, or if I want to check whether the limit is existent or not, so the existence of a limit, if I evaluate, so what is the limit existent means? So in a case, if you say that if a function is there, so for the function f of z is a complex variable function. So let me just take a complex variable case. So this is a complex variable function. Then the limit, for example, let me just take that L of f of z at a point z0 exists if and only if. So if you want to verify whether the limit exists or not, then you want to check what? You want to check that let limit z tends to z0, f of z should be equal to what? It should be equal to L. Okay, so this value, when you say that, this value should be always what? Should be finite one. This L value should be finite and unique and should be a single valued. Okay, so along a very possible path of z tends to z0. Okay, then only we call it as the limit is existing. So whenever you say that, to check the whether the limit exists or not, so that limit f of z tends to z0 should be equal to L. Okay, where L is the limit representation for that case, or rather we can also set that this L must be independent of the path along which z tends to z0. So in all cases you should have a representation corresponding to the, in order to check the limit exists or not. So let me just go through an example. So we'll work out on an example, then you will understand how do we verify whether the limit exists or not. Okay, so we'll just do represent, just note down limit z tends to z0, f of z should be equal to L. Okay, so let me just say that I'll have a representation z. Okay, so the first question we'll address on this one is, that is, we'll have a representation. So where you have to prove that limit z tends to 0, z by z bar does not exist. Okay, does not exist. So this is the first question regarding this existence of limit. You can note down the representation above. The existence of limit will be verified if a function of f of z is a complex variable function, then the limit L of f of z at point z0 exists if and only if limit z tends to z0 f of z equal to L. So it should be finite, unique and single valued along every possible path, that is z tends to z0. That means L must be independent of the path along which z is traveling to z0. Okay, so we'll come back to this problem. How do we do this problem? So let me just introduce you this one. So what do I do is that, so I'll be just checking, so limit z tends to z0, right? So that is z by z bar, we have representation here. So that is equal to, I can introduce, what is z I can introduce as x plus iy, right? So divided by what is z bar. Z bar means is a complex conjugate of the complex number, that is x minus iy. Okay, so this is a representation we'll have here. And now if I consider uh, along y-axis, so along y-axis, if I represent along y-axis, if you just say, so we know that in that way x will be equal to 0 along y-axis, right? Along y-axis x will be equal to 0. So that means the limit x tends to 0, y tends to 0, f of z is equal to limit x tends to 0 and y tends to 0, that is x plus iy divided by x minus iy. So when you represent in this case, what we said that x will be equal to 0 in that case, right? So if that is the way, if he is following, in this case x will be equal to 0, so you can substitute x is equal to 0 here. So x is equal to 0 means, so you will have limit, first you apply the limit x tends to 0, then you will have limit y tends to 0 will be equal to what? That is y divided by minus iy. Okay, so when you represent this one, then you will be having the value, that is minus 1 will be a corresponding representation, so that you will be getting a minus 1 value here. And let me just take the next case, so that you will be understanding much better. So that is, in this case along x-axis, if you consider the path is along x-axis, so in that case y will be equal to what? Y will be equal to 0. So that first you have to apply y tends to 0, then x tends to 0, f of z. So f of z is here, it is limit y tends to 0, x tends to 0, x plus iy divided by x minus iy. Okay, so that is limit x tends to 0. When you apply along x-axis, that y will be equal to 0. So that what you will be getting? You will be getting x minus 0 divided by x plus 0 divided by x minus 0. That is what you will be getting 1 as the representation value. Since the limit is not unique, so the limit does not exist in this case, because when you check them in both cases, whenever you consider along y-axis, this has the value -1. When you consider along x-axis, this value is 1. Okay, so that means the values of the limit values actually what it is interchanging when you consider different axes. That means we can say that since the limit is not unique, okay, not unique, so limit does not exist. Okay, hope you understood, because if the limit exists, you should get the both the values should be equal to either 1 or -1. Okay, this should be in both cases, the value should be either 1 or -1. Okay, then only we can say that it is a unique limit, so it limit does not exist in this case. Okay, so we'll examine the next case, then you'll be understanding much better, I think. So that is, we'll have the next question. So I'll having check limit z tends to 0, z by z bar square whole square exist or not. Okay, check that whether check z limit z tends to 0, z by z bar whole square exist or not. So here also you can do the same way, that is limit z tends to 0. So what is our z by z bar? Z by z bar I can introduce like the limit z tends to 0, that is x plus iy divided by x minus iy the whole square. Okay, so I can do represent like that. So that now let me consider the first case, that is along y-axis. Okay, along y-axis. So in that case, first you have to apply limit x tends to 0 and y tends to 0 and x plus iy divided by x minus iy the whole square. Okay, so that we know that along y-axis means what? X will be equal to 0 in that case. Okay, so when you apply that, you will be having the value, that is limit y tends to 0 will be equal to, you have to substitute x equal to 0. So x equal to 0 means you will be getting value will be equal to what? You will be having 0 plus iy divided by 0 minus iy, okay, square. So that is, you will be getting value will be equal to what? You will be getting this will be whole square, right? So let me just, okay, so that is y tends to 0, that is 0 plus iy divided by 0 minus iy the whole square, right? So that is, I'll be getting limit y tends to 0 into -1 square. Okay, so when you substitute that, you will be getting the value will be equal to what? You will be getting the value will be equal to 1 in this case. Okay, so you will be getting 1 in this case, that is -1 square. Okay, so in the next case, when you consider along x-axis, so we know that y equal to 0. So when you apply limit y tends to 0 and x tends to 0, that is x plus iy divided by x minus iy the whole square, it is equal to what? It is equal to, you will be getting limit x tends to 0, you have to substitute y equal to 0, okay, so that you will be getting x plus 0 divided by x minus 0, okay, the whole square, that is you will be again getting one value, okay. And now let me introduce in the case, okay, so in this case itself we can say that it is almost like what is, this is unique, right? So this is unique limit, this limit having limit values are unique. So because both cases we are getting the same value, that is 1, so the limit values are unique and does exist, okay, so the limit exists as well, okay. So this will be the scenario in this case. So from whenever evaluating only these two cases, what we can get is that we'll get an idea that the limit existing in this case, right? So that is the idea we'll be getting, but it is not that exactly correct when you consider another case, that is if you consider along y is equal to mx, because we see that when you consider z tends to 0, you have to consider all the curve that is possible to here. So let me just take into the consideration y is equal to mx. So in that case, limit x tends to 0, x plus I mx, because y is equal to what? Y is equal to mx. So that is x plus I mx divided by x minus I mx whole square will come, okay. So that is limit x tends to 0. So in that case you'll have, if I take x outside, 1 plus I m divided by x plus, sorry, x into 1 plus, not 1 plus, 1 minus, right? So x into 1 minus I m, so the whole square will be there. So this is how it comes in this case. And now if I evaluate limit x tends to 0, okay, then we can cut down this x here. So I'll be getting 1 plus I m divided by 1 minus I m, where m is the slope of the line. And now if I say that y is equal to, if I substitute y is equal to x and y is equal to 2x and y is equal to 3x, that means what? M equal to 1 in this case, m equal to 2 in this case, and m equal to 3 in this case. So if you represent the values of m value, for example, if m is varying with respect to different lines, we know that in this case the limit value will change, right? Okay, so depends on m, so the limit will have different values. So in this case, so since we are getting different values for limit, so the limit is not always finite, so does not exist, okay. So this is how you have to address any problem or any function you are given to, so given means you have to check the existence of limit will be checked by like this, okay. First you have to check along y-axis and along x-axis. If you are getting both cases, you are getting the limit having unique value, then you should not say that directly from that point itself it is exists. Instead you have to check the another way, that is you have to check with the another slope or y is equal to mx place, okay. And in that case again this function is actually finite and unique, then you can say that it is the limit is existing. And now in this case what we observed is that the limit does not exist in this case, okay. So that is the one important aspect you have to note down whenever you consider checking the existence of any limit. Okay, so let me just move on to the next case, that is about continuity. So here we understood how do we check the existence of any function, complex variable function. So now we'll come to the case of continuity. So continuity, how do we check the continuity and all? So for that, what we'll be doing is that, one second. So continuity of a complex variable function, how do we verify that? Okay, so continuity, if a function f of z is a complex variable function, then it is said to be continuous at point z0 if and only if first case is, there are different conditions corresponding to that. The first one is limit z tends to 0, f of z should be equal to L. So that means the limit should exist, right? So the limit should exist in that case. And the second case is that if you consider f of z0, so f of z0 should be also exist, then you can say that it is continuous. And what it means is that when you represent any value, so that is limit z tends to z0, sorry, limit z tends to z0, limit z tends to z0, so in that case f of z should be equal to what? It should be equal to f of z0. Okay, then only we can say that f of z0 exists in this case. And also in addition to that, whenever you say a function to be continuous, so z tends to z0 should be what? It should be possible along every path, right? Z equal to z0 and independent of every path along which. Okay, because we know that for this we have another condition as well, that is along every possible path this should be possible. Possible path limit should exist and unique should be, right? So if whenever z0 is tracing any path, in that case the limit should exist. And also we said that it should be independent of the path, because this value should be common in all cases. Independent of every path, the value should be constant for all the path it is tracing. Okay, so in all cases when z is tracing towards z0, the limit value should be a constant value, should be unique and finite and single valued in that representation. And now let me just say that, so already we said that how do we check the continuity one? So it should be limit should exist and f of z0 should be exist. How do we check the f of z0 exists or not? For that you have to take the limit z tends to z0, f of z should be equal to f of z0. Okay, so you have to give the value corresponding to that. So now let me just introduce you two function here. Okay, so let me just introduce you two function here. So you note down one point, that is if f of z and g of z, these are the two complex variable function, so are considered to be two continuous functions. Okay, in that case we can say that f of z plus g of z also will be continuous function. Okay, so whenever you have like this, and also we can say that f of z minus g of z also will be a continuous one. Okay, will be also continuous. And similarly, if you do the multiplication of this function g of z and f of z, so it is also again a corresponding representation. Okay, now we'll have a third case. In this case, we'll have the representation, that is f of z, f of z divided by, so that means that division is coming between two function. So in that case also this will be continuous. So if and only if, in that case, g of z should not be equal to 0, that is this complex function should not be equal to 0 in that case. And the fifth case, so these are just casing, considering when you are two complex variable function, whenever you have f of z equal to u plus iv, so this is a continuous function, then u and v are both will be what? Both will be continuous in that case. And similarly, we can say that whenever u and v are a continuous function, then f of z will be also a continuous function corresponding to that. Okay, then how do we check that? So we'll do one problem, then you will understand how do we check whether the function is continuous at the origin or not. Okay, so we'll do one problem, then you'll understand much better. So here I just represented, if there are two complex function, complex continuous function are there, then you can say that the addition, subtraction, multiplication and division cases and all will be continuous for those two functions. And whenever you have f of z equal to u plus iv, then u and v will be both will be continuous. And similarly, if u and v are continuous, you can also say that f of z equal to u plus iv will be a continuous function. Okay, then how do we check the continuity? We already said that the limit should exist, that's the first condition. And second condition is that f of z0 should exist. How do we check that? That is limit z tends to z0, f of z should be equal to f of z0. Okay, so we'll go to one problem, then you will understand better. Okay, so here what we will be checking here is that, here just check that, show that, so here show that the function f of z equal to, there are two conditions here, real part of z divided by z, where z not equal to 0 is not continuous at origin. Okay, okay, then the second one is f of z equal to 0 when z is equal to 0. So when z is not equal to 0, real part of z divided by z is the function. When z equal to 0, then the function will be equal to 0. Okay, so how do we check the continuity in this case? So the continuity, for in order to check that, so first we need to check whether the limit exists or not. So in the first case, when you consider, so let me just write it down here. So that is f of z is equal to what? It is real part of z divided by z, then this is 0. This will be equal to, in the case z not equal to 0, that is we can consider this case will be z tends to 0. Okay, so that is f of z will be equal to what? Real part of z divided by z. So this is a case where the limit is z is tends to 0. When z equal to 0, so the entire function becomes what? Entire function becomes 0. Okay, so that's the case we have given. So we'll first consider along y-axis. Okay, along y-axis, because why we are checking that? because we have to check first, we have to verify that whether limit exists or not. For that, let me just take that along y-axis. So this will be the imaginary part, right? So this will be the imaginary part we will be having. Okay, so limit x tends to 0 and y tends to 0, and real part of z divided by z. Okay, so that is equal to limit x tends to 0, y tends to 0, like we have done earlier. So here real part of z means what? That is only x value will be there, right? X divided by, then x plus iy will be there on the representation. And now we say that in this case along x-axis means what? Along x-axis means, sorry, along y-axis means x will be equal to 0, and the corresponding representation limit y tends to 0 will be equal to what? 0 divided by 0 plus iy. So that is equal to what? You will be getting finally 0 here. Okay, so along y-axis whenever you check the representation of the limit value L will be equal to what? You are getting 0. So along x-axis, so along x-axis, so if I check, so it is a real axis, right? So the real part of the axis. So over here we have to check that limit y tends to 0 and x tends to 0. So that is, we will be evaluating the function real part of z divided by z, that is limit y tends to 0, x tends to 0. Real part of z means it is x divided by x plus iy, that is equal to limit x tends to 0. So in this case what? Y will be equal to 0, right? So that is, we'll have a function that is x divided by x plus 0, that is equal to 1. So in this case, since we have the function is not unique along every possible path, so we can say that it is not a continuous at all. Okay, so first by checking whether the given function, so the given function f of z, given function f of z is not having unique value, is not unique along every possible path. Okay, every possible path for z tends to 0. So we can say that limit does not exist in this case. Okay, if the limit does not exist, then we can directly say that f of z will not be, so f of z is not continuous, because this is one of the conditions to be satisfied in order to a function to be continuous, because it should be first the limit should exist, then we have to check that f of z0 is existing or not. Okay, so that is what we understood from here. So from by just checking the limit exists or not, we can came to a conclusion that f of z is not continuous in this case. Okay, so that is what we understood from here. So let me just introduce you a next problem. So in that case, what we need to do is that, so here show that z dot z bar is not continuous. Sorry, is continuous. Okay, it will be a continuous function. Yes, it's a continuous function. So okay, control. So show that z into z bar is continuous function, continuous at origin. So that z dot z bar is continuous at origin. How do we do that? So here our function f of z equal to what? F of z is equal to z into z bar. Okay, z into z bar is the corresponding function we are having here. So that is equal to what? This is equal to x plus iy into x minus iy. So we can write like this, that is I'll be getting x square minus I y square, because we know that a plus b into a minus b is equal to what? A square minus b square. But that y relation we can directly write like this. Okay, so that means x square minus y square, because I square means minus 1, sorry, this will be plus 1. Okay, x square plus y square will be the corresponding representation. Now in this case, first we have to check that the limit z tends to 0 is exists or not. Limit z tends to 0, f of z exists or not. That is, we have to check first, right? So if you check that along y-axis, we know that limit x tends to 0 and y tends to 0. F of z is equal to limit x tends to 0, y tends to 0. Here our function will be x square plus y square. So that is, if I substitute in this case what, x equal to 0. Okay, so I'll have limit y tends to 0 means what? That is 0 plus y square, that is equal to 0 will be the corresponding value. Okay, and similarly along x-axis, where y will be equal to 0, when you apply limit y tends to 0 and x tends to 0, f of z, that is equal to limit y tends to 0, x tends to 0, x square plus y square, that is equal to limit x tends to 0, x square plus 0. That is, once you apply the limit, then x tends to 0 means you will be getting again the value will be 0. And now we need to verify with that another case, that is along the line y is equal to mx. Okay, so that limit x tends to 0, because in this case if x is getting to 0, y will be automatically 0, right? So we are only evaluating with respect to x, so that x square plus y square, so this is the function we are having. What is x square here? X tends to 0, x square plus y square means that is m square x square. So I can represent like that. So that is equal to limit x tends to 0, because whenever you have x tends to 0, then this becomes what? This I can either write it as x square into 1 plus m square. So this will be equal to again 0. So that means in this case the value of limit f z 0. Okay, the limit tends to 0, f of z is equal to 0 in all cases. So it is unique in all possible path. Okay, so we can say that limit exists. So in this case limit exists. So our first condition is satisfied in order to check whether the function is continuous or not. Now the next step is in order to check whether at z is equal to 0, because we said that at origin whether it is continuous or not. Okay, so at origin we know that z will be equal to what? 0 at origin. So f of z equal to z into z bar. Okay, that is f of 0 will be equal to what? 0 into z bar. Okay, that is equal to 0. Okay, so this is the first case we have to check. So from that we will understand that f of z0, okay, f of z0 will be equal, f of z0 will be equal to 0 in this case. And next one, we need to check also limit z tends to 0, f of z should be equal to what? Should be equal to f of 0. So we are getting the same response corresponding to that as well. So that is the given function f of z equal to z into z bar is continuous at origin. Okay, it is continuous at origin. Okay, so this is how you check and prove whether a given function is continuous or not. Okay, so I'll be giving a homework assignment for you to do on checking the continuity. So this is the homework for you. Note down, check the continuity of the function f of z is equal to xy divided by x square plus y square when z not equal to 0. Okay, and 0 at z equal to 0. Okay, so you check this function, check the continuity of the function f of z equal to xy by x square plus y square when z not equal to 0 and 0 at z equal to 0 cases. Okay, so like we have done in the last two problems, check the continuity of the different values corresponding to that case. Okay, so this is how you do the continuity check of a case. So now let me come to the case of differentiability. Okay, so let me come to the case of differentiability here. Because I said that initially today we will be discussing limits, continuity and differentiability of the complex function. So the next one is differentiability. Okay, so differentiability, or we can rather say that derivability or existence of a differential coefficient. In any way you can say that. So if any function to be differentiable, if a function f of z is a complex function, then it is said to be differentiable at a point z0 if and only if, okay, if and only if f dash of z0 exists. Okay, f dash of z0, f dash of z0 means limit z tends to z0, f of z minus f of z0 divided by z minus z0. Okay, so if f dash of z0 exists, so this is existing means you have to check this should be unique value. Okay, this should be unique and a finite value and should be single valued. Okay, along a very possible path, a very possible path of when z is tracing towards z0. Okay, അപ്പം z ൽ നിന്ന് z0യിലേക്ക് വരുന്ന ഏതൊരു പാത്തിലും ഇതിന്റെ വാല്യൂ എന്ന് പറയുന്നത് യൂണിക്ലി ഡിഫറൻഷ്യബിൾ ആയിരിക്കണം. സെക്കൻഡ് വൺ എന്ന് പറഞ്ഞാൽ എന്താണ്, ഇറ്റ് മസ്റ്റ് ബി ഇൻഡിപെൻഡന്റ് ആസ് വെൽ. ഇറ്റ് മസ്റ്റ് ബി ഇൻഡിപെൻഡന്റ്. നേരത്തെ ലിമിറ്റ് എക്സിസ്റ്റ് ചെയ്യുന്നിടത്ത് പറഞ്ഞ പോലെ ഇറ്റ് മസ്റ്റ് ബി ഇൻഡിപെൻഡന്റ് ഓഫ് ഓൾ പാത്ത് along which z is tends to z0. Okay, so ഇതാണ് ഇവിടെ മെയിൻ ആയിട്ട് നോക്കേണ്ടത്. എഫ് ഡാഷ് ഓഫ് z0 എന്ന് പറഞ്ഞാൽ ലിമിറ്റ് z tends to z0, that is f of z minus f of z0 divided by z minus z0 എന്ന് പറഞ്ഞ എക്സിസ്റ്റ് ചെയ്യുന്നുണ്ടെങ്കിൽ this value should be unique and finite and single valued at all paths and it shall be independent of any path it follows. Okay, so ഇത് എക്സിസ്റ്റ് ചെയ്യുന്നുണ്ടെങ്കിൽ നമുക്ക് എന്ത് ചെയ്യാൻ പറ്റും, അതൊരു യൂണിക് സിംഗിൾ വാല്യൂഡ് വാല്യൂ ആയിരിക്കും കിട്ടുക. ഇനി ഇവിടെ നമുക്കൊരു note ചെയ്യാനുള്ള point ഉണ്ട്, that is NB, that is not the point here, that is differentiable function. Okay, so differentiable functions at any point are always continuous. Okay, this is very important one. So all the differentiable function at any point will be continuous at that point too. Okay, if any function is differentiable at any point, that are always continuous as well. And the second one is that continuous function at any point, this is the first one, and the second one is continuous functions at any point may or may not be, okay, may or may not be differentiable. Okay, but any differentiable function at any point will be continuous. Okay, so continuous function at any point may or may not be differentiable, so you have to note down that point. So let me just do one example here, and after that we'll just wind up today's session. Let me just introduce you one example to verify whether it is differentiable or not. Okay, so this is a question number 1 for this section, that is show that the function f of z is equal to z bar is continuous at z is equal to 0, but not differentiable at z is equal to 0. So that the function f of z equal to z bar is continuous at z equal to 0, but not differentiable at z equal to 0. Okay, so how do we do this one? In order to do that, here we given function is f of z equal to z bar, so that is x minus iy, x minus iy. So as we said, we can check whether that is continuous or not. So I am not going to do whether it is checking it continuous or not. Instead, I will be directly going to say that this is continuous because this is a polynomial function, right? Okay, so this is a polynomial function. Since it's a polynomial function with the powers of x and y, so it will be always what? It will be always continuous. So I am directly moving to that conclusion. So in order to save time, or rather you can do like the earlier exercises we have done in order to verify whether a function is continuous or not. നിങ്ങൾക്ക് വേണമെങ്കിൽ നേരത്തെ നമ്മൾ ചെയ്തിട്ടുള്ള സ്റ്റെപ്പുകൾ വേണമെങ്കിൽ ഒന്ന് ചെയ്ത് നോക്കാം, കണ്ടിന്യൂസ് ആണോ ചെക്ക് ചെയ്യാൻ വേണ്ടിയിട്ട്. അതല്ലെങ്കിൽ തൽക്കാലം അതൊരു പോളിനോമിയൽ ആയതുകൊണ്ട് ഞാൻ തൽക്കാലം എന്ത് ചെയ്യുന്നു, അതൊരു കണ്ടിന്യൂസ് ഫംഗ്ഷൻ ആണ് നമുക്കറിയാം. നമ്മൾ പറഞ്ഞിട്ടുണ്ടായിരുന്നു ഇറ്റ് വിൽ ബി സിംഗിൾ വാല്യൂഡ് ആൻഡ് യുണീക്ക് എന്ന് പറഞ്ഞിട്ട് നമ്മൾ എന്ത് ചെയ്തിട്ടുണ്ട്, അനലിറ്റിക്കൽ ഫംഗ്ഷന്റെ കേസ് പറയുമ്പോൾ നമ്മൾ പറഞ്ഞിട്ടുണ്ടായിരുന്നു. തൽക്കാലം ഞാൻ ആ ഒരു ഐഡിയ വെച്ചിട്ട് ഞാനത് കണ്ടിന്യൂസ് ആണെന്ന് പറഞ്ഞിട്ട് ജസ്റ്റ് ഡിഫറൻഷ്യബിലിറ്റിന്റെ കാര്യം ചെക്ക് ചെയ്യാൻ വേണ്ടി പോവാണ്. നമുക്കതാണല്ലോ ഈ സെക്ഷനിൽ പറയേണ്ടത്. ഓക്കെ, സോ ദാറ്റ് ഈസ് എഫ് ഡാഷ് ഓഫ് z0. f dash of z0 should be equal to limit z tends to z0, okay, f of z minus f of z0 divided by z minus z0. So this is the first rule in order to verify whether a function is derivable or not. So here z0 equal to what? It is equal to 0. Okay, so f dash of z0 means what? F dash of z0 is equal to 0. So that is equal to limit z tends to 0, f dash of z minus f of 0, sorry, f dash of z illa, f of z, f of 0 divided by z minus 0. Okay, now if you evaluate this one, we know that the function limit z tends to 0. What is the function f of z? F of z is z bar, z bar minus 0 divided by z minus 0. So it comes like this. So we know that what is z bar is, so that is limit z tends to 0. This I can represent as x minus iy divided by x plus iy. Okay, clear? So further, now if I evaluate along y-axis along x-axis, what do I get is that if z is, in this case, if I just evaluate along y-axis, in that case we know that x will be equal to 0. So that is limit x tends to 0, then y tends to 0, x minus iy divided by x plus iy, that is equal to limit y tends to 0. You have to substitute x is equal to 0, that is 0 minus iy divided by 0 plus iy, that is equal to, we know that this value will be equal to minus 1. And now along x-axis, that means y will be equal to 0 in that case. So in that scenario, the limit will be equal to what? Limit x tends to 0, sorry, y tends to 0. Okay, then x minus iy divided by x plus iy, so that is equal to limit x tends to 0, that is x minus 0 divided by x plus 0, that you will be getting 1 as the value. Okay, so in this one we got minus 1, another case we got another case we got 1. Okay, so that means what we can say that f dash of 0, okay, is not unique along all possible path. Okay, path of when z is tends to 0. So this is, it is, so it does not exist. So the limit does not exist in that case. Okay, and also we said that in that case f of z is equal to z bar is not differentiable. It's not differentiable at z is equal to 0. Okay, so this is the conclusion from that side. And similarly, in similar fashion, you can also verify on different function. So I'll give you few function where you want to check whether it is differentiable or not. In some function you can directly move on to the, if you get some polynomials, you can directly move on to the representation that it will be continuous, and you can directly go and check the differentiability in that case on different path. That is very important. Okay, so that's why we y-axis, x-axis and all we consider, because different path the differentiable value should be unique. Okay, then only we can say that it is differentiable in all direction and it will be unique valued as well. Okay, so that is what more important in this case. So you just check verify. So I'll be giving one more function. So that is, you can take it as homework. The function is show that f of z equal to z square is differentiable only at origin. Differentiable only at origin. So this is the first one you have to do. And the second one is that prove that z dot z bar is continuous everywhere but nowhere differentiable except at z is equal to 0. Okay, so these are the two homework problem, and the earlier one more problem we are also given. So finish those three and come to the next class, that is on Monday. Okay, so okay, so that is about the discussion of differentiability, single valued, and continuity and limit existence of the representation. Okay, do and understand the different aspect, because further moving with the Cauchy integral theorem and all, these are very important to understand. Okay, so understand what is the limit existing or not, continuity, and the differentiability of any complex variable function. Okay, and remaining portion we'll do on the next class, that is about Cauchy integral theorem and all. Okay, so be ready for the next class by finishing all these